In this video, we will be going over the law of cosines and its use in solving for the unknown values of given triangles. For our first problem, we have been asked to write the law of cosines for the given triangle. The law of cosines is as follows. The side length x squared is equal to the side length y squared plus the side length z squared minus 2 times the side length y times the side length z times the cosine of angle x. The side length y squared is equal to the side length x squared plus side length z squared minus 2 times side length x times side length z times the cosine of angle y. And finally, the side length z squared is equal to the side length x squared plus the side length y squared minus 2 times the side length x times the side length y times the cosine of angle z. For our next problem, we have been asked to solve for the unknown values of the following triangles using the law of cosines. In order to find each of these angles, we have to set up the law of cosines for each one. We will first set up the law of cosines for x. We know that the side length x squared, or in this case 8.0 squared, is equal to the side length y squared, which is 3.8 squared, plus the side length z squared, 5.7 squared, minus 2 times the side length y, 3.8, times the side length z, 5.7, times the cosine of angle x. Solving for angle x, you should find that it has an angle measure of 113.2 degrees. Next, we repeat the same process for the angle y. So the side length y squared, 3.8 squared, must be equal to the side length x squared, 8.0 squared, plus side length z squared, 5.7 squared, minus 2 times side length x, 8.0, times side length z, 5.7, times the cosine of angle y. Once again, plugging this into your calculator, you should find that the angle y is equal to 25.9 degrees. Finally, solving for angle z, the side length z squared, or 5.7 squared, must be equal to x side length squared, 8.0 squared, plus side length y squared, so we have 3.8 squared, minus 2 times side length x, 8.0, times side length y, 3.8, times the cosine of angle z. Solving for angle z, you should find that it has a value of 40.9 degrees. We can go ahead and plug these values into our unknown positions. X was 113.2 degrees, y was 25.9 degrees, and z 40.9 degrees. If you would like to check your answer, you can verify by noting that all of these angles are the total angle measure in a triangle and should add up to 180 degrees. So by taking 113.2 plus 25.9 plus 40.9, you should get out a value of 180 degrees in total. For our next triangle, we repeat the same process. We first need to solve for the side length z in order to find the values for angle x and angle y. And so we must say that side length z squared will be equal to 11 squared, side length of x, plus the side length of y squared, which is 9, minus 2 times side length of x, 11, times the side length of y, 9, times the cosine of angle z, which is given as 36 degrees. Solving for the side length of z in this equation, you should find that z is equal to 6.47. We can then go ahead and solve for the angle x. We can say that side length x squared, 11 squared, must be equal to side length y squared, 9 squared, plus the value we just determined for the side length of z, 6.47 squared, minus 2 times the side length of y, 9, times the side length of x, 6.47, times the cosine of the unknown angle x. Solving for angle x, you should find that it has a value of 89.11 degrees. Finally, solving for angle y, we say that side length y, 9 squared, is equal to side length x, 11 squared, plus side length z, 6.47 squared, minus 2 times side length x, 11, times side length z, 6.47, times the cosine of angle y. The solution for angle y should come out to 54.92 degrees. And so we can go ahead and plug in our unknown values, 6.47 for the length of z, 89.11 degrees for the angle x, and 54.92 degrees for the angle y. These three angle measures in total add up to approximately 180 degrees. And so for our last problem, we have been asked to solve for the triangles that satisfy the given conditions. The first triangle, we are given a side length of x is equal to 7, a side length of y is equal to 9, and a side length of z is equal to 5. We can use these values along with the law of cosines to determine the angle measures for angle x, angle y, and angle z. We will begin by solving for angle x, taking the side length x, 7 squared, being equal to the side length y, 9 squared, plus the side length of z, 5 squared, minus 2 times 9 times 5 times the cosine of angle x. Solving for angle x, you should find that it has a value of 50.7 degrees. Next, we will solve for angle y. We begin by saying that the side length y of 9 squared must be equal to the side length of x squared plus the side length of z squared, or 7 squared plus 5 squared, minus 2 times the side length of x, 7, times the side length of z, 5, times the cosine of angle y. Angle y should be found to be 95.7 degrees. For our last angle z, we take the side length z, 5 squared, being equal to the side length x, 7 squared, plus the side length of y being 9 squared, minus 2 times the side length x times the side length y times the cosine of angle z. And so we find angle z to have a measure of 33.6 degrees. Our answer can be verified by noting that all three of these angles, 50.7 for x, 95.7 for y, and 33.6 for angle z, will all add up to 180 degrees, or the total angle measure of a triangle. We can first solve for the side length of x by noting that the side length of x squared must be equal to the side length y of 10.4 squared plus the side length of z, 7.3 squared, minus 2 times the side length y, 10.4, times the side length of z, 7.3, times the cosine of angle x, which is 131 degrees. Plugging in and solving for x, we find that it has a length of 16.2. Next, we can solve for our angle measure y by saying that the side length y, 10.4 squared, must be equal to the now found side length x of 16.2 squared plus the side length of z, 7.3 squared, minus 2 times 16.2 times 7.3 times the cosine of the unknown angle y. Plugging this into our calculator, we find that the unknown angle y should be equal to 29.1 degrees. Next, we can solve for our angle measure z by stating that the side length of z, 7.3 squared, must be equal to the side length of x, 16.2 squared, plus the side length of y, 10.4 squared, minus 2 times 10.4 times 16.2 times the cosine of the unknown angle z. Solving for z, we find that the angle measure is 19.9 degrees. Verification of our answer can be done by noting that the angle measure of 131 degrees plus the angle measure of y, 29.1 degrees, plus the angle measure of z, 19.9 degrees, will all add up to 180 degrees. That concludes this video on the law of cosines.